to Unit 6, Video 3, Intermolecular Forces. So now that we understand polarity and how we can get a polar and a non-polar molecule due to the distribution of charge, intermolecular force is going to tell us why molecules can attract each other. So when we're dealing with intermolecular forces, we have to deal with two or more compounds coming in together. And what's going to happen is we're going to get maybe a positive, more positive end or a more negative end. And remember, equal and opposite, opposite charges attract. So if we get a more positive end, we're going to get kind of a negative end is going to come in and kind of, get a little stickiness, kind of stick towards it. So if we look at kind of the three examples of intermolecular force, the first one is something called LDF, or London dispersion force. London dispersion force is the force of nonpolar molecules. Okay, so in a nonpolar molecule, remember we have an equal distribution of charge, so we don't have a dipole. So we really don't have a more negative or a more positive end. So if we have something that looks like this, now remember, electrons are constantly moving in space. So we're going to constantly have the electrons kind of moving around the compound. So what happens is maybe at a split second in time, let's say we need to have two compounds, we have more electrons on this side, so maybe we get a negative end here for half a second or for very, very small amounts, and maybe we happen to have a little bit of a positive end here. So what's going to happen is we're going to get a little bit of a stick together here because we've got a slight positive, slight negative. Now remember, this is random distribution of charge because while this is equally dispersed in the molecule, the charges, we might at some point in time have more electrons on one end and less electrons on another end. So we're going to get a slightly more positive. Okay, and we're going to call this the random distribution of charge for London dispersion force. Okay, now, and the London dispersion force is very weak. It's a relatively weak compound, weak intermolecular force. The larger the molecule is, the higher the force becomes, or the more powerful the force becomes, because we've got more electrons, more distribution of charge, so we can get more random stickiness to the other molecule. Now, if we look at something that has a dipole, that means it's going to be polar, so we know that one end is more positive than the other. What's going to happen is the other compound is going to come in line with the end that maybe is more positive or more negative. So here, the negative end will align with the positive end. Okay, and same thing here, and we get a stronger bond here, or stronger forced attraction to each other, because remember, opposite charges attract. So what happens is we get the more positive end wants to bond, or wants to come closer to the more negative end. Okay, so this is called the dipole, bonding for intermolecular forces. Now, the last force we want to look at is something called hydrogen bonding. Okay, so hydrogen bonding is only going to happen in polar molecules also. So dipole is only polar. It does not happen in nonpolar because no dipole occurs in a nonpolar molecule. So if we were to look at something, let's look at something such as water. Okay, in order for hydrogen bonding to occur, we have to get the bonding with nitrogen, oxygen, or fluorine. That means hydrogen must bond to nitrogen, oxygen, or fluorine. So what's going to happen is we know that this electron is this oxygen is way more electronegative than the hydrogen. So we're going to get a pull towards the oxygen here. Well, what's going to happen is this oxygen is maybe going to have a hydrogen that's going to come in and it wants to be attracted to this oxygen here. So it's going to grab onto these the oxygen here is going to grab the lone pairs and form kind of a stronger bond here between the hydrogen and the oxygen. So what we call this is hydrogen bonding. Okay, hydrogen bonding means it's a little bit stronger of an intermolecular force. We know that the hydrogen bonding is why we have high surface tension in water, because those molecules want to stick really close together.